Hey fellows, this is Zhang, KD2TAI. Today we're going to talk about something fun about HT and DTMF. If you haven't heard about what they are, HT is just handheld receiver, transceiver actually. DTMF is about the dialing tone, and combining these two things together can make a lot of fun. And specifically, we are going to talk about some theory about simple digital communication for handheld transceiver and other transceivers actually. This is nothing sophisticated like FT8 and other real digital mode, but you will get a feel of it and probably inspire you that you're gonna start researching your own digital mode. You can do that. So a little bit about myself. I'm formerly known as Zhemin. I'm currently studying at RPI undergrad in computer science and computer system concentration, focusing on digital communication and AI technologies, which if you really put that into plain English, is analog and digital hardware and software. I'm the current president of the W2Z, this RPI radio club. I was first licensed as in my freshman year, I think it was 2 or 3 years ago, and then recently upgraded to extra class earlier this year. So DTMF, if you never heard about that, you probably heard about it. I mean the tones, the dialing tones, especially when you press on the keypad, and still today when you dial on the smartphone, they'll still emulate that kind of sound. And if you wonder what that is, that's DTMF, okay? Dual tone multiple frequency, which means that dual tone, if you press a button that generates 2 sine waves simultaneously, and you have multiple frequency that you can choose from. Basically, it's split into two groups. You have low frequency group that's below 1 kilohertz and another one above. So let's say when you press key 1, in this case, you will have the low frequency group 697 hertz, and also one frequency from the high frequency group that is 1209. That is the combination that's going to produce when you press the key 1, and that applies for every other key. What's special about this keypad rather than actually the one you see on the phone is that you have A, B, and C, D, the extra 4 keys, but that actually makes the entire set of DTMF, while the phone doesn't, only has the 12 keys, because A, B, C, Ds are basically reserved for net control and other use. But anyway, on most of the HT nowadays, even including UV5R, you actually have these keys. So that's great. And just in case you're interested, these are the precise frequency and the symbol table that you can look up from Wikipedia. So let me talk about setup. And at this point, I know that you guys really want to see the real demonstration, real live demonstration about the setup that we have. And very unfortunately, about 2 days ago, after about 2 years of service, one of the decoder module chip actually died. I think I shorted something out because it smoked. But never mind, we can still go this on paper. I will show you this is not going to be, the end of the world, I guess. So the system block diagram. First of all, you need an RF receiver. It can be handheld, mobile, or base station radio. And you have an audio cable that's connecting the both audio jack from your radio to the decoder, which is located on the board, the module MT8870. It's one of the dirt cheap module for DTMF decoding. And combine that together with Arduino, you actually send hexa digits, I mean, through the serial port to your computer, which is, preferably running Python or any other programming language that you choose. And optionally, you can also have relays, also other kinds of actuators you want to use. But in this case, it's just purely code, so no relays. That is the real picture of my setup. a mobile radio for reception. It has an audio cable that's going to the module that's near the keyboard, and going to the laptop. And on the laptop, it's just running one of the Python program that's decoding the image, the colored image. One of them we have here. The budget for a decoder is about $20. Include shipping and tax, everything, which is quite affordable. So if you want to give it a try, then just give it a try. It's cheap. And one more question before we actually go to the next step is how to send DTMF tones. I'm just using UV5R as an example because I know most of you have at least one of these in your shack. So to transmit, you hold the PTT and then you press the button. You will not be able to hear unless you have a receiver, another receiver on the side, but you're actually transmitting it. All right. So you press the button that you want to transmit. It's just like dialing, right? Nothing much different. And then you release the PTT, and that's all. So see how easy that is. Well, we can definitely just transmit some random DTMF tones as if we were dialing, but we better follow some kind of encoding schemes to actually represent information in a manageable way. So binary encoding is probably one of the easiest and one of the most fundamental coding scheme. If you're learning computer science, that's great. You can probably skip this part. But if you don't, here's a basic theory behind it. So we have 16 keys, right? And how many binary digits you actually need to represent all 16 combination? The answer is 4. You can write this out actually. Start from 0, 0, 0, 0, and you plus 1, counting the binary until you reach 1, 1, 1, 1. And you will figure out that's 16 of them in total. And we have 16 keys for DTMF tone keypad at least. So you can do one-to-one mapping fairly straightforward. Hex digits. So what's that different from binary digits or bits? Nothing really much different. It's just an easy way to notate everything. So you have 1 hex digit for every 4 binary digits. It just makes things a lot shorter and easy to talk about. And in the lookup table, you can see how they're corresponded. The binary 0 to hex 0 to decimal 0 and to DTMF simple 0, right? And then it just goes on and on, except if you really look into the hex digit E and F, we don't really have corresponding in DTMF symbol. So it can be just a star or a pound. It doesn't matter which one is which, as long as it is consistent in your system, but that's what I suggest. And equivalently, why I'm saying that 1 hex digit represents 4 binary bits, it also means that 1 DTMF key press or 1 symbol also carries 4 bits. So now here we have an updated map of A, B, C, D, E, F, and 0 through 9. That's just the hex digit that's mapped on the keyboard to each of the symbol. And we talk about bytes now. So we just talk about bits, right? Bytes is typically 8 bits because 1 bit is a yes or no, 0 or 1, true or false. That's not quite informative. And in order to practically represent something, we usually talk about bytes. Given that each DTMF tone actually represents 4 bits, it takes 2 symbols, 2 key press to make 1 byte. For instance, if I want to transmit this byte made of 8 bits, 1010, 0101. It's just arbitrary. It has a good pattern of it, right? Then if you look into the lookup table, 1010 gives you A, 0101 gives you 5. So what you're gonna do to transmit this byte is press on the keypad A5. That's it. And congratulations, now we can actually send any arbitrary data. at least bytes. However, we still need some sort of standards, the agreement on two sides, or two operator or two computer, or one side of operator and one side of computer. That's, what does this byte actually means? Or, when we send a string of bytes, and how should they, how can we interpret them, right? So we come across with some of the existing standards, which actually turns out to be pretty helpful. One of them is ASCII, abbreviated from American Standard Code for blah, 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 represent text in computers and other devices. So I think ASCII was invented back in the 70s and 80s, with one of those, early models, teletypes, and mainframe to terminal, etc. It was very widely used. And if you really look, let's have a closer look here. If you really look into it, you'll see there's only 127, 0 to 127, which means that 128 symbols in total. And that's only 7 bits, you might think, because 8 bits gives you 256. And we are wasting 1 bit. It doesn't matter, because now if we just make everything in the powers 2, that would be a lot easier for computers to tell, which is actually more efficient. So, there's a trade-off. And if you look at the table, and you may figure out that there are symbols, numbers, letters, and uppercase and lowercase. So it's actually a pretty comprehensive set, at least for English. Fortunately, you'll not be able to contain any sort of emoji or, other sort of things into this ASCII table, because it only has such little space. It's 2 to 7. But it's still good enough for our situation where we want to send text. So here was just one example. If we want to translate code to text, just go online and find a ASCII lookup table, get that ready in your hand, and now you'll start looking at what is 43 or 43 in hex digit means. If you really look it up, it means capital letter C. And Q, that's 51. What does 20 mean? 20 means space. 44, that's going to be D. 45 is E. It's just +1. They comes in sequence, and etc. If you just go doing this, again and again, you eventually get a string out of it, and that says CQD KD2TAI. And it works the other way too. The mechanism is fairly similar. So you look at the capital letter Q, and oh, good, we just learned it. It's 51, right? Then you go for S, 53, L for C, space is 20, and etc. So this is usually, and very efficiently done by computer. But just in case you want to do this by hand, this is still doable, because next step, we are going to transmit pictures, which would be a lot more information containing just a very small picture. So texting good. What about pictures? One thing we can do with them is to treat them like text. If we can encode pictures in text, that would be great, because we already know how to send text. PPM, image format, is just one of the many, many schemes that you can actually encode pictures into text, right? You can represent the image to the right into ASCII code, which says P1 space 3 space 2, new line 1 space 0, and alternating 1s and 0, which if you really have a closer look at it, P1 stands for the black and white bitmap encoded in ASCII mode, and 3, 2 suggests the image width and height. The following bits, alternating 1 and 0, basically says that what each pixels are. If that's color picture, there will be a slightly different header. That's going to be P3, I think, or actually P5. P3 is reserved for grayscale. But anyway, so that's how you represent pictures. If you translate the ASCII starting with P1 into hex digits, the keystroke that you're going to have on the keypad. That's what it is, 50, 31, 20, 33. These keystroke will actually transmit a picture like this, and we'll be able to recover on the other side of the receiver. So now we can encode pictures by now, other files, right? Zip, movies, perhaps, MP3, all sort of things we can think about, just arbitrary binary files. You can do them in this way or sort of similar way. One of the scheme, again, is called base64. It's a binary to text encoding scheme, blah, 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 for sending email attachments. If you're interested in the, how it actually works, it has every 6 bits that's mapped to one of the printable characters. So now you can transmit almost anything on the devices that can only allow characters. For instance, teletype, or even one of the earliest typewriter. You can actually type entire song encoded in this format, and of course in the characters, upper and lower alphabet plus numbers plus the plus sign and slash, that you can transmit these kind of thing, arbitrary binary strings on the paper using a very classy typewriter. Just nobody's doing that because it's too hard, too much effort. We are just using one example here, and notice that we are just using text. We're encoding text in ASCII into base 64, which is very unwise. You will see that in a second. But usually what you're going to do is to base 64 coding of zip files or image that, things that they're sent along with email, because the email system, the SMTP protocol, only handles the 7-bit ASCII characters. So you will have 24 bits that's coming from 3 bytes. You just read 24 bits at a time, and then you regroup them into 6 bits instead of the 8. So now you will have 4 base 64 symbols, and you translate that into the character. So now you have man, M-A-N, man in capital M, now into TWF with a lowercase u. So you see there's a little bit of overhead when you encode, and definitely you don't want to do this with text, but it works well for other kinds of formats. With that little bit of overhead, you're able to transmit things that's usually not able to transmit through the media that usually doesn't work. Well, for instance, you have a JPG file in the left, and if you encode that into base 64, you have a blob of text like that on the right-hand side. So definitely at this stage, you don't really want to transmit manually, but instead letting 2 computers talk to each other. Right? So now we are at one of the final applications that I'm thinking of. You can probably think of better ideas, but this is the coolest thing that's probably I'm doing in the recent years. That's terminal over DTMF. Terminal, if you don't really understand what it is, it's basically like a command line that allows you to talk to the machine, but this can be done remotely, like SSH. But instead of SSH, that's using the internet, that we are having this terminal over DTMF actually over a real radio link. So here's a concept that you will start with some serial terminal program in your computer, a mobile station, and you want to access the computer at home, right? What you're going to do is that you start a program called screen. In this case, it doesn't matter which one it goes. It can be minicom, picocom, putty. We're just choosing screen, for instance. That goes in through the hardware codec that we have in this setup. It goes through the Arduino, and Arduino will do a bit of bit group and ungroup, and then it sends the information to the DTMF encoder module, which you can also purchase at a very reasonable price. the audio tone is being transmitted through your mobile, perhaps FM radio, and over the air until it's being picked up by one of the base station at home, and then it decodes the audio, and it's being sent to the sound card of a radio codec. A software codec. We're gonna explain that in a while. Then it's being grouped or ungrouped, and then sent to the computer. The pseudo teletype is one of the concept in Linux or Unix system, if you're not familiar with, and vice versa. All right, so in this diagram, you also figure that we can either have hardware codec or software codec, which is totally feasible if you're having a modern computer like laptop that's built at, after a year to 2010, that you can have simple programs that detecting whether there is a frequency present at the one of the 8 frequencies and decide which symbol you actually received, and therefore you decode everything. And this can be also done manually, but I think you wouldn't be able to do that in real time. It's just way too hard. But there's a lot of possibility out of this encoding scheme that we can potentially make full use of. So that's really the end of the presentation. Questions and answers. Any questions are welcomed. Have a good one.
Okay. I guess I'll leave that. No, I'll take that off. I was going to leave that on there, but
yeah.
Eisen, that's an interesting concept, interesting project, and hope that folks viewing will have some questions to ask. We're not seeing anything in chat yet, but please, anybody have any questions, please add them in there.
Yeah, any comments and criticisms, that definitely help. It's more, I would say this is more like a education project, maybe. I don't know. It's more for like educational use rather than practical use. But at least it gives you a general idea of how the digital communication system works.
That's kind of clever using the DTMF. I mean, most everybody has a handheld radio, and they typically have a DTMF keyboard on them. So it's kind of an interesting thing. I like you say, I think it's educational. I think it's something for people to experiment with, and basically try something different, and maybe learn some other schemes that they could come up with. But it's interesting because that's about as simple as you can get in terms of encoding and decoding. That's pretty cool.
Right. Well, it can probably replace one part of the system to, one of the more sophisticated scheme. Well, for instance, you don't really have to use the DTMF. Instead, use QAM.
Right.
Let's say 64 or 128. That gives you 7 bits per symbol, and that just, that almost doubled the efficiency of the system.
Yeah, you double the efficiency of it. Yes, exactly. And so it's if you're thinking about it, if you're trying to learn how certain encoding schemes work and modulation schemes work, that's kind of a good introduction to it, because it's similar to teletype, using frequency shift keying, but it's you're actually using 2 tones simultaneously rather than 1 tone at a time. So you have the ability to transmit more data, more information at one symbol. So it's interesting. It's an interesting concept. Oh,
I didn't really cover that the difference between symbol and bits. Oh, we do have a question. Yeah.
Hey, we got a question. Eugene. We have a question.
Yeah. Basically, I would say that's comments. But thanks, thanks for everybody being here and showing your interest here. Yeah.
Yeah.
It takes time to process. Yes, it might take some time because we are actually going through a complete digital communication system. It's just that some of the part where you being naive, but again, it is a complete system, and it takes some time to actually internalize the things we're doing here.
It's great. And Walter has an interesting comment here. Yeah, there you go. Yeah, it is an interesting comment for using DTMF. It's really, really great.
Yeah.
Uh-huh.
Yeah. And while you can do this just by hand, again, you want to make it more practical. You can always go for that the module, the decoding module. Couldn't recall the part number, but we do have slides, so definitely go back and check. It's like $5 or even less than that dollar cost. So
there's the decoder, the encoder and decoder chips. Yeah, you could actually do that way. Mm-hmm.
Right.
Actually, used one of the a DTMF decoder as a decoder for CW, for Morse code, and just used because it's a phase lock loop. It's it's a all integrated, and you just pick one frequency and let it receive that, and then that was fed into an Arduino to do the decoding. So that was familiar with those devices. But a couple more.
Yeah. Do you use this method regularly? No, as I said, it's more like for education purpose than being practical. So I did some testing actually over the year with my friends. We were able to transmit like binary files in smaller length because we don't really have any like error correction mechanism in this case. But that's again something that you can add on. We are just talking about a minimal, simplistic a setup that you can learn from it. Yes. Is there isolation or matching needed between? We just use audio cable, so it's not being played through speaker or anything like that, right? So I guess isolation that you mean is that are we playing through speaker and a mic, right? No, we're just using audio cable.
I was gonna say normally, you use like when we're using like a modem on a computer going to a radio, you usually have some kind of isolation transformer or something like that. I suspect that's what he's asking about. Yeah.
Right. Right. So it's sort of like we are making our own modem because we have the decoder board and the Arduino. Right. Okay. Next question.
I like the next.
How long does it take to transmit a big picture? So it actually depends because JPEG has different ratio of compression. If you have some computer science or just computer engineering background, there JPEG can have different compression ratio. Plus, you can have different color depths. Like the more color you have, it takes more bits to represent certain pixel, so that overall you have more information and longer time to transmit. But as we tested, each symbol, the spacing will be like 40 milliseconds. It sounds really insane, like somebody's dialing real quick, real fast, but it still takes quite a long time to transmit something that big because you're almost asking like thousand by thousands of a million, right? So it's like a million pixel stuff. And for each pixel, assume that you're doing color. That will take like probably 8 bytes, and think about it. So I haven't really calculated the figure, but you can get a feeling of how long would that take. Yeah,
and it's going to take a while.
Extended period of time, probably overnight. It's like people were sending pictures back in the old days when they're using modem over the telephone before internet actually exists. So,
right, 300 baud modem. Yeah.
Yeah.
I remember those days.
Yeah. The next one, ground loops. I don't really catch that. What do you mean?
Well, in you've always got that problem of ground loops when you're interfacing things, and that's one of the reasons you use transformers is to isolate that. I think in just experimenting with this and doing something simple like what Hyson's talking about, I don't think you really need to worry about ground loops very much. I don't think that's going to be an issue. Typically, what you'd have in a ground loop is you'd be doing things like picking up hum, 60 hertz hum, and that type of thing. And if you're on a handheld and if you're just punching the keys on the handheld by manually, you're not going to have a problem with that. But yeah, if you built some kind of an interface to your computer to do this with a sound card, sound cards just using an audio cable, yeah, you're probably not going to have a problem with that. I can't imagine that being a real serious issue. I mean, there's lots and lots of designs online you can search for audio interfaces for any kind of radio, a handheld radio or whatever. So, there's some really simple ones that don't use a transformer or anything, and you don't worry about the ground loops. You interface a laptop to your handheld radio. So
because in this case, it doesn't matter as we experimented.
Yeah.
Perhaps for higher speed transmission, it might be an issue, but with the 40 millisecond hold of one symbol, it doesn't really matter that much. Yeah. It's like why it's like 40 milliseconds. It's just like the time for the chip to detect a symbol on the module. Anything shorter than that may not guarantee a good decoding result. So.
Yeah, and the other thing is that if you had a ground loop and you had 60 hertz in there, or 120 hertz even,
it doesn't matter.
It doesn't matter because it's outside the passband of your filters. So
right.
it's going to ignore that.
Plus, we want to care about 8 frequencies in total.
All right. Let's see. Well, some good comments and good questions.
Yeah.
I guess I should mention, as everybody knows, in case you didn't know this, that this is being recorded and it will be available for 30 days after the expo ends. Eric indicated that the videos are going to be available, I think, after Tuesday at the latest. I think so. I was checking out this morning. Some of them on the well, can't even think. It's too early in the morning out here in California. On the list of programs, some of them have a little play button, but I don't think it's working yet. I was fiddling around with that this morning a little bit, some of the earlier presentations, and it just sits there and spins its wheels. So I don't think they're loaded up yet, but the function is there to be able to play the video. But I think Tuesday is the target date for everything. So it was Paul's comment. You'll have a lot of opportunity to go back and check it out later on once the video's back up. And
and in case you have any more questions or any detailed questions about slides, some point that I may not be clear, please email me. I actually have my email included on the slides. So definitely, please do.
Yes, absolutely. Always good. Wow.
We're probably waiting for more questions.
Yeah, for some more questions. Yeah, it's unfortunate that the folks at home can't see the chat questions. You can only see what you type. You can't see what other people type, but we get to see that. And it's kind of unfortunate that because that might lead someone to another question. You never know. But I think we've basically hit everyone that's been asked. We've brought everything up, so I don't see any new ones. Yeah, there are some interesting quirks that we see on this platform that you don't see at home. Is that there's a timestamp on everybody's comment here, and it's always 4 p.m. So it's kind of funny.
Right.
Here you go, Eugene.
It seems to me like yes, yeah. It's like everything's 7 p.m. or something.
Yeah.
Yes. Oh.
Yeah.
Oh.
Right.
Everybody can see them. Oh, nice.
Oh,
yeah. Yeah.
You do actually. Well, we are actually taking the comments and putting them up on the screen here is what we're doing here.
Oh, things getting piled up. Yeah. Actually, yeah. So, thank you again. Thank you all for coming.
See, there's
right. Right. Please comment on telemetry over radio. I was actually talking about the terminal over radio. It's like, I think we were talking about different things, but actually this can be used as, sort of mean for telemetry because you can send the data through the radio. It can be arbitrary data, right? So um, let's say you're doing some measurement, remote sensing, and then you want to transmit something back using your HT, then this is totally feasible. Because as you learn, we can encode everything to text, and you know exactly how to transmit text over radio now. So, but if you have any particular question about telemetry, then you can probably just keep asking. Yes, we still have a lot of time for Q&A session.
Yeah, absolutely. Yeah, and I just saw that somebody had made a comment. Walter makes a comment that they've changed it, and I just went over and looked on the other computer, and I'll be darned if they didn't change that from the way it was. So you can see questions from everybody. So that's great. That is super.
Definitely.
Yeah. Yeah, that was kind of unfortunate. We were thinking that the other night. We did a live stream on Friday night, and it was we couldn't really tell what was going on. But yeah, 4:35 GMT. Yes, indeed.
Yeah. Bye. Yeah. Thank you.
Yeah. Thanks for coming.
Yeah.
Yeah.
Yeah. You can probably talk a more background story. No, sorry, interrupting you.
Yeah.
But
go ahead. That's your job.
There might be a delay. Yes, I'm thinking of talking about this. Actually, it's somebody inspired me doing this. Like he's the WTIZ club advisor. That he presented some idea to have a binary protocol that people can communicate over radio. So that sort of inspired me. That why not just map DTFM tones into the binary groups, so that now we can transmit almost anything instead of just following his protocol. We can reuse many of the protocol that we already have in the computer world that was even invented back in 70s or 80s, and they were still very useful, right? We don't have to reinvent the wheels. So given that, I created this sort of project or bit of study, and hopefully that will inspire more people into this field, just like how Brian inspired me in one of the club meeting. Do you have more questions? No. Actually, I wonder how many people actually attended this live session. I believe a lot of people just will replay like what I'm doing for this. Yes, because time conflict. I do have commitment for something else during the weekend. Sort of busy. But yes. Again, any question? If you have any question afterwards, please email me, and I will be happy to answer. More than happy.
You can actually put your email up here in the.
Up on the may I couldn't really type.
Do you?
To the. I think I can only type to you.
Yeah, give me your email in the. I can get it off the other computer here, but just type your email in there, and I'll put it up here on a caption.
Yeah, that looks good. No spelling mistakes. No.
Okay, you can just put that right here and add that, and then play it. There we go.
Right.
So that's available for everybody now.
Looks about right.
Yeah. Hopefully you got it right there.
Right.
I'll leave that up there for a few minutes. And,
right.
So we get some more questions or comments.
Yeah, some more questions. Right.
This would be. It strikes me that this would be something good for. We always talk about getting youth involved, young people involved in amateur radio, and thinking about kids that are, young kids that are getting into programming and coding and all of that, and getting into ham radio, combining those two things, this would be an interesting project for something simple that kids could
QRZ. Yes, I am on QRZ, and you'll see my bio and some publications and projects I'm doing. Some are really interesting, I think, but we can only share one thing at a time. So definitely check that out. So,
yes. Yes, indeed. Yeah, you do have some interesting stuff going. We were talking a little bit about that yesterday when we chatted, and you got some interesting stuff going on. So, forward to hearing more about those things in the future.
Right.
It's all good.
That's why we share, because I am inspired by somebody else, and I want to inspire somebody else from, my advancement in this topic, so that we eventually promote the entire ham radio community.
That's true.
Yes. Worked for years for paid phones and modern. Yeah, across. Yeah, I missed most of the presentation.
Yeah, Kurt. I'm gonna go ahead and show. Well, let's show that. That's an interesting comment. Yeah, this is the fact that DTMF tones have been around for decades. And you're right about payphones, modems, fax machines, everything used that for their connections.
Yeah,
and it's good. And yes, it cut off part of the text here, but yeah, these this is being recorded, Curtis, and they'll be available on the QSO Today website. There'll be links to all of these. In fact, if you go up and look at the agenda right now, you'll see that there's a play button on the agenda for each topic that's starting to show up, but I don't think they're live yet. So it's going to take a few days for that. I think they're supposed to be all finished by Tuesday of this coming week. So you'll be able to go back and look at all these videos.
Right.
So as well as the commentary as well. So right.
And payphones, it's sort of side topic, but there is a really good presentation, I think, made by the 8-bit guy. I don't know if you actually anybody heard him. 8-bit guys focus on the retro computing and retro technology, and he's on YouTube. So the 8-bit guy, definitely check that out. There is one presentation that he made at some convention about telephone freaking using blue box and other tricks. It was wonderful. Like, explain how the entire system works and how this can be corrupted, but not nowadays anymore, because 8-bit guy, yes,
that's it.
Or perhaps the 8-bit guy, whatever. Yes.
Okay.
Call it Dave or yes. So,
okay. So yeah, I can.
That's the name of channel, right?
I can. Let's see. Where are we? Yeah, I'm not sure. I'm not exactly sure of this, but this is the idea: is 8-bit guy or the 8-bit guy or something along those lines. On you said on YouTube,
right? Telephone freaking. There is a video about it. Yeah. How the different system, like payphone system, can be tricked by using a whistle or something. That was, I think, coming from a toy that come along with some cereal breakfast, something like that. Yeah. So
that's right. That's where it started. Yeah, there was a whistle that was in a box of cereal.
Yeah. If you cover up one the whole, it actually make a perfect tone. That will trigger the thing. So.
Yeah, you mentioned, boy, I date myself by talking about any of that stuff. But yeah, the days of blue boxes and phone freaking and way to get past the long distance charges on a payphone. Good old days. Yeah,
and they're computerized word dialing or something like that. Well, it's definitely before my time. I was definitely not born back then. I'm still in college anyway. So yeah, but I learned a lot of interesting from him, and I think it's actually pretty important if you learn something. Check it out its history, because the way things are today are actually evolved from the very beginning. It takes time, and there are many reasons that you see the things as it is today. So
Yeah.
definitely learn the history and think about why it ended up this way, and perhaps we can learn something out of it to apply in the future. Where are we going to move?
That's right.
Yes, where are we going to move to next? So,
David comments 2600 hertz. I think that would have been 2600 cycles per second back in those days, but
yes,
yeah.
different terminology.
Yeah.
Yes.
But that's good. Yeah, 2600. Oh yeah. That was a
yeah, that was like I don't know, it's like hand up tone for the local exchange or something, that you can trick the local exchange that you're still calling some free numbers, 180, 1-800, but
1-800.
yeah, 1-800, but you're actually dialing to some other number. So yeah,
I like that. Yeah, that was. I think you're right.
Captain Crunch. Yes.
Captain Crunch.
Yes.
That was it. Yeah, I think you're absolutely right.
Yeah. You all know this much better than I do, because you lived when you can possibly exploit this system, but I couldn't. So
yeah, the fact that that's all coming back, that was a long time ago. Mm-hmm. I can't even remember what I had for breakfast, much less what was going on back in the 60s and 70s.
Oh, Captain Crunch, isn't it?
No, it wasn't Captain Crunch. I didn't have Captain Crunch for breakfast.
Oh. Yeah.
That's funny. That's great. Well, yeah, you're right. Talking about the older technology, retro technology, that's one of the things that I love is the retro stuff. And yeah, you look behind me, you can see some of it. Vintage gear and understanding the old technologies and being able to work with the old technology. That's kind of a fun thing to get into.
And even though they are obsolete, I mean, they're the foundation of today's technology. And if you master then, it'll be much easier to understand what's going on now. So.
But the interesting part is, this is the thing that a lot of people miss, is I may have radios here that are older than I am, but they still work today, and they're compatible with the radios that are produced today, single sideband and all of that. The modes, haven't changed, and they're fully compatible. And that's a big problem with commercial systems, is you have interoperability issues, right? One of the beauties of ham radios, we really don't have that problem, because even though I've got technology that's 50 years old, it's still interoperable with the stuff today. And that's one of the cool things about ham radio to me.
Yeah. I probably have a different view on that topic. But yes, let's actually discuss it. It's Q&A session. Sure. Nobody's asking more questions. So yeah. So I think in the early stage of technology development, especially, I mean, that holds true for almost any items, that in the early stage, a lot of things can actually stay compatible with each other, right?
Yes, that's right. Mm-hmm.
Right. Yeah. But as things getting more complicated, it might be harder. Well, let's say that, the letters or the literature people wrote over the past 7 years will be compatible with what we write today, because we can actually learn things on this plain primitive medium. But things are changing, because nowadays you probably couldn't play the thing that you recorded on VHS back in the 80s. While you can still read something that people has handwritten thousands of years ago.
Yeah, that's right. That's right.
So the more technology has advanced, I think it might be harder to actually make things compatible. So ham radio in this case, something invented 100 years ago, the AM or SSB later on, are actually fairly simple, and they're early stage of this technology. And I think as digital modes goes on, we might have difficulties remaining things compatible over the time.
This is a very good point. And one of the things that I like to gripe about is photography. I've done photography most of my life, and I've got a huge archive of analog photographs, stuff that's on film. And I can, Kodachrome transparencies that are 50, 60 years old. I can go look at those and they're perfectly fine today. But I've got CDs that I recorded images on just a few years ago that I can't read. It's like,
because you have to learn that digital scheme before you can actually assume something that you know the format and how to unpack it. But it's unlike AM, it's fairly straightforward, and you can always find a way to demodulate it.
Always demodulate it. Yeah, it's simple to demodulate. Yeah, and the format, the file formats, the encoding formats change. Those old ones become obsolete, and you don't have access to the equipment to be able to read or decode that material. Interesting, reading an article recently, Smithsonian, the Smithsonian Institution archives a lot of media, and some of that media is quite old. And there's a guy at the Smithsonian whose sole job is to maintain all the equipment that's used to read all those old medias, like an old Betamax recorder. It's like you mentioned VHS. Just trying to find a VHS machine today is not exactly easy. It's going to get harder and harder. And I know the article was commenting about the fact that he spends a lot of time on eBay finding these old.
It's his job. Then it must be a wonderful job, though.
I was going to say that's a fun job. I would love to have a job like that.
For many ham radio operators,
it'd be great. Well, I got my own problems that I have to maintain here with all the vintage gear, but and there's never a dull moment around W60Q here. That there's something always breaking. It's not just the old gear either. The new gear breaks too. I've been having nothing but computer problems the last couple of days with this stuff, but it seems to have settled down now. My audio's good, and at least I think it is. Everything sounds good on here, so hopefully you're hearing me okay. But I was having some serious audio issues over the last couple of days. And Doug, you're welcome. This is fun.
Actually, I want to make. Sorry, go ahead.
Yeah, go ahead, please. This is
actually to Paul. Thank you, but yes, I don't intend to interrupt. But Paul, I want to make a point here. So you probably want to use the speed of sound instead of speed of light to do that division, right? Because otherwise, wavelengths will be insane. It doesn't quite make sense in that case.
Actually, if you're into ultra low frequency stuff, it does make sense. But that is audio rather than RF. But you could do 2600 hertz at 2600 hertz at RF. In fact, that's one of the things I'll tell you. That's one of the things that I'm into here is VLF and ULF. Listening to some of the really low frequency stations that are you'd consider in the audio range, but they're actually radio transmitters. There's quite a few of those around the world. And
for the marine control command and stuff, because they penetrate water much better than high frequency.
Right, exactly. But it takes gobs of power because of the long wavelengths. But one of the most interesting ones from a scientific standpoint you can bring up is what's called the Schumann resonance of the Earth, which is around 8 hertz. And it's basically the Earth's environment creates a resonant cavity with a resonant frequency of 8 cycles per second. And it's energized by lightning strikes. And there's roughly 300, on average, about 300 strikes per second around the world. And those put enough energy into that cavity that you can actually detect that with a receiver that can go down to that frequency. And the perfect receiver to do that is a sound card on your computer. You can use an antenna instead of a microphone and actually receive those signals. So that's kind of a neat thing.
It's more like learning from the interference rather than the radio signal itself, right?
There you go.
Yeah.
Yep.
Unused railroad signal
Unused
lines.
railroad signal lines, yeah, because that's a good comment. Yeah, if you're on a field day and you find some old lines that are out there that aren't connected to anything, they got to be disconnected. You don't want to hook up to them if they're connected to something. But yeah, use that as an antenna. Then you're usually miles and miles and miles of wire. So,
Right.
Not recommended.
Yeah, because I think there are actually systems using the power grid to transmit information. Yeah. So if you want to operate a 2200 meter band, I think you have to avoid interfere with that. So
that is true, and you're actually limited, I think, to the physical size of your antenna, unfortunately. So you're limited to.
You still want a quarter wavelength antenna for that?
Yeah,
500 meters.
Yeah, exactly. Copper thieves love them. Yes, exactly.
Yeah.
You're limited to the antenna length of the antenna, as well as your ERP is limited, and you actually have to do a survey before you get on some of those frequencies. You have to file a survey that determines how far you are from power lines that are actually using those low frequency, the carrier modulate, what they call it, carrier current modulation is, I think, the term used.
Yeah.
You know, we fought vigorously against something called broadband over power line a few years back. If you remember that, that was putting broadband internet over the power grid, and really bad idea. That is no longer a transmission line; it is now a radiator, and it's right in the HF spectrum. That was miserable. So I feel sorry for anybody that has to put up with that, because I know there are some systems that were deployed. But we fought with the ARRL to get that shut down, and thankfully we were successful. So, yeah.
That comes to a study of how to locate RFI. It will be a completely different subject.
Oh yeah, there's a lot of good material on that too online. Ed Hare with the ARRL W1 RFI. He's a good expert to speak with, and he's done a lot of talks on that, on dealing with interference, and mitigating interference, and tracking it down, and all of that.
Yeah. I don't know if it was him, but in a fairly recent Ham Expo in Northeast, we do have some topic about like how to locate RFI. It could be him, actually. I didn't went to that panel, but yes.
You know, I know I don't think there was anything this weekend, but if you go back and look at some of the older QSO Today Ham Expos, there have been subjects on tracking down RFI, and there's a lot of good information out there. So if you're plagued by that, and I will tell you that I am from time to time here, and it's becoming a bigger problem as time goes on because of technology. You know, we're getting more people are going to solar, and they're having inverters that are not necessarily clean, and they generate a lot of hash, and it radiates, and we pick it up, and that's a problem. So you have to track that stuff down, and there are good tools for doing that. Yeah. I was going to comment. Yeah, I'm watching the time. We've got a couple of minutes left. I have noticed that the system, I think, shuts down the stream automatically, because I think a couple of the programs I was watching yesterday got shut down in the mid
very end. Oh,
yeah,
no.
so I want to make sure we leave ourselves a little buffer there so we don't get cut off. But
right. Just determine this elegantly.
Elegant termination, yes, that's a good way to put it.
Right. Yeah, great discussion. Thank you.
Yeah, thank you, Paul. It's, well, you know, this has been fun. I enjoyed your presentation, Hyson, and I want to go back and look at it again. And I looked at your QRZ page, and you got some interesting stuff going on. And I know we're going to be talking in the future. That's for sure.
We will be talking.
Yes, and I'm going to hopefully get you to come and speak on Rat Pack.
Yeah, at some time. We do have one presentation that is ready, but not yet being sent because some organization issue. So,
well, I'll go ahead and I'm going to go ahead and shut this down before they cut us off. So, everyone from both of us, 7-3, and thanks for attending. And,
thank you, 7-3.
Yeah, take care, everybody, and stay safe. And I'll see you over in the preview.